GLP-1 drugs have exploded in popularity for weight loss and have long been used for diabetes treatment. But now researchers are asking what they can do for aging. And that's the topic of this week's Healthcare Triage. In your body, GLP-1 is a hormone released by cells in your gut after you eat. Its job is to help control blood sugar and let your brain know that you're full, which it does by stimulating insulin release, suppressing glucagon, a hormone that raises blood sugar, slowing down digestion, and signaling satiety in the brain. Pharmaceutical drugs called GLP-1 receptor agonists mimic these actions, but are engineered to last much longer in the body than the natural hormone, which is broken down only in a couple of minutes. Clinically, these GLP-1 drugs have been game changers for people with type 2 diabetes and more recently for people looking to lose weight for a variety of reasons. But the story doesn't stop there. GLP-1 is really having a moment, with evidence suggesting that its broad role in physiology might result in far-reaching effects we weren't initially expecting. Scientists are now exploring whether GLP-1 drugs might have benefits in the realms of aging, cellular resilience, and cognitive health. Early evidence from animal studies suggests GLP-1 receptor activation can impact fundamental processes linked to aging. These include improving mitochondrial function, enhancing cellular stress resistance, reducing chronic inflammation, and supporting brain health. This early evidence has some scientists hypothesizing that GLP-1s could help cells better cope with stress and damage, which are key factors in aging, and that this might translate to a longer health span, which is defined as the period of someone's life spent free from major disease. This is all very exciting, but we wouldn't be Healthcare Triage if we didn't pump the brakes a little. The science behind GLP-1 is still evolving. Not all of the optimism around its benefits has panned out in clinical trials, especially in areas like neurodegenerative disease. Early hopes that GLP-1 might slow Alzheimer's progression haven't been confirmed in large randomized studies, and some major trials were stopped early when results were disappointing. Researchers are legitimately excited about the possibility that GLP-1 biology intersects with aging mechanisms, offering a window into extending health span. But this area is still early, and translating animal or cellular findings into human benefits is far from certain. And of course, GLP-1 therapies are not without downsides. Side effects and limitations exist, and they are not a replacement for lifestyle measures like diet and exercise. Their effects also tend to depend on long-term use, and stopping them usually leads to a reversal of some benefits. But at the end of the day, GLP-1 biology has moved from an obscure gut hormone to a central player in modern medicine. Its current applications in metabolic diseases are profound, and its future potential in aging and health could reshape how we think about chronic disease and longevity. But that future is still being written, so we'll wait for the research to unfold. Hey, did you enjoy this episode? You might enjoy this previous episode on a discovery study of GLP-1. We'd really appreciate it if you'd like this video and subscribe to the channel right down there. And maybe go on over to patreon.com/healthcaretriage where you can help support the show, make it bigger and better. We'd especially like to thank our research associates, Joshua Crow, Edward Liljeholm, and Christopher Learn, and of course, our Surgeon Admiral, Sam.